And we can take out our highlighter and highlight this piecewise notation. And what is it used for? It's when you have a graph that's actually a bunch of different graphs glued together. It has a bunch of pieces. Like the absolute value graph is like two straight lines glued together. We could find the equations of each of those straight lines separately and say this piece is this and this piece is this. So for example, they have here BC Wild Park offers discounted rates for groups of 10 or more. Right? If you have only 1 to 9 people, you pay $10 per person. 10 to 99, $8, 100 or more. I can't imagine bringing a field trip to a park with 100 people, but I guess you could. Then you're only paying $7. So the piecewise function, the way that we write it, is we write one function. Here's the rate. And then we use a squiggle bracket and write each of the different pieces. And for each piece, we say what domain goes with which piece. So between 1 and 9 people, then you had $10. Between 10 and 99, then you'd have $8. And over 100, you'd have only $7. Here is the piecewise function for an absolute value graph. Now, if I draw your regular absolute value graph in blue here, this is the graph of the absolute value of x, which if you imagine drawing all of the inside function, this part, which I'm going to highlight in green, that's just part of y equals x. But this part that I'm going to highlight in red, that has a negative slope. That would be the graph of y equals negative x. And so the way that we write the absolute value in piecewise notation, we say it's equal to x whenever the x values are positive, and it's equal to negative x whenever the x values are negative. So when we go to our example here, we want to write each of these in piecewise notation. What we have to figure out is where that x-intercept is. Right? So again, sometimes it's helpful to start with the graph. If I started with the graph, I could grab the inside 2x minus 1. I'll do that in blue. We would have a y-intercept of minus 1, slope of 2. And most importantly, our x-intercept here is at 0.5, comma 0. When you plug in 0.5 for x, you get 0. Then the absolute value graph, this part would stay the same, and this part would get flipped up. That's our absolute value graph. It's going to have two pieces. So to draw the piecewise notation, right, y equals, the one piece is the piece that stays the same. That's 2x minus 1. And that happens if x is bigger than or equal to a half. So we have to find that x-intercept, and this original part, that stays the same. 2x minus 1 is when it was originally positive. The part that gets flipped up, when we flip it up, we change all the y values to negative. The easiest way to write this is to take the original graph, 2x minus 1, and put it in brackets and a negative in front of it. And that's when x is less than a half. Notice I included the equal sign with one of them and not the other one in my inequalities. Because technically, even though it's the same point at that one, you can only have it defined for one part. So you have to break up your domain, include a half in one of them, but not in the other one. So that's why there's an equal sign in the first one and not an equal sign in the second one. adding that negative in front takes the part that was negative and flips it over the x-axis. And now we have both pieces. You could distribute this negative afterwards if you wanted. You see that if you distributed that negative, you would get negative 2x plus 1? Do you see that right here we have that y-intercept of plus 1? So your other option is you could just do y equals mx plus b for that line and say, I know my y-intercept, I know my slope is negative 2, and could write it that way.
Why do we only put a bracket on one side?
It's weird. That is a good question. I don't know. I've often had that question as well. Why don't we, it just feels like we should have a squiggle bracket on the other side to keep it together. Because like what happens if my equations just run off because there's no bracket on the other side? I'm not sure. Then for part B, again, now we have a parabola. If I was graphing the inside first, okay, it's not in, I'll do this inside in blue, let's graph. So we have to know all of our graphing skills from chapters 4 and 5. How would I go about graphing this? Well, it's not in standard form. I don't know the vertex. I could choose to try to change it to standard form. That could be an option. I could also write this one in factored form. I could take out a negative x, leaving me with x plus 3, and that would help me because I could tell that I have an x-intercept at 0 and an x-intercept, oops, not there, at negative 3. I know that my parabola opens down. If those are my two x-intercepts, then my vertex and my axis of symmetry would be right here at x equals negative 3 over 2. And so I could plug in negative 1.5 into this equation and find my vertex. It's going to be somewhere up here because I know this parabola opens down. So what happens? We have, with the absolute value, which I'm going to now graph in green, this part would stay the same, this part would get flipped up, and this part would get flipped up. How do I write that in piecewise notation? And I'll show you that we could write this in 3 pieces. The answer key writes it in 2 pieces. I'll talk about that afterwards, yes.
If we don't have different colors, how do we differ, like, do we need to include the original graphs line as well, or can we just erase that so that it's not?
So one of the things you can do is you could draw the original one maybe with a dotted line, and then write the equation and label it that way, if you just have a pencil. Or sometimes people draw the original one on one graph, and then just start a new graph for the one where they flip it up. It's nice to see exactly the same part if you draw it on the same one. Then for a piecewise function, I'm going to break this up into 3 pieces, okay? Because we have, and I'm going to start from the left and move to the right. Our first piece got flipped up. So I'm going to take my original equation, which was negative x squared minus 3x, put it in brackets and put a negative in front of it. And my first piece was with x less than or equal to negative 3. Then my piece between negative 3 and 0, that stayed the same. So that would be negative x squared minus 3x if x, and if you want to write in between, we'd go negative 3 less than x less than 0. And finally, it got flipped again. When x was bigger than or equal to 0. Now, since the pieces share these x-intercepts, it doesn't matter where you include the equal sign. If you look in the textbook, I think they included the equal sign when they did this middle section. Okay? And in the textbook, you notice that these two pieces are the same equation. They combine them. So you have a choice. I kind of like working from left to right, so I wrote it in 3 pieces because of that. If you wanted to combine the x less than or equal to negative 3 and the x bigger than or equal to 0 together, you could. But what happens is there's no one, well, there's the absolute value, but if we wanted to write this as actual equations without the absolute value, we'd have to break it up into pieces. So questions for practice on piecewise notation? 8, 9, and 13.